Next chapter, algebraic expressions. Now, an algebraic expression is one that contains variables and constants. Letters are used to denote variables, and so a variable can take various values which are not fixed. On the other hand, a value that does not change is called a constant. And so in an expression 2x squared plus 3xy plus 8, x and y are the variables, and 8 is a constant. An algebraic expression is formed by combining variables and constants with the help of operations such as addition, subtraction, multiplication, and division. And so for an expression 2x plus 4, it is formed by first multiplying a constant 2 with the variable x and then adding a constant 4 to the product. Equally, 8p minus 21 is obtained by multiplying a constant 8 with a variable p and then subtracting a constant 21. So in these two examples, the expressions are obtained by combining variables with constants. You can also obtain expressions by combining variables with themselves or with other variables. For example, x squared plus xy is formed by multiplying the variable x with itself and then adding it to the product of the variable x and y. Terms of an expression. Now, consider the expression 3x plus 5. In forming this expression, we first multiply 3 times x and then add 5 to the product. So this expression has parts which are formed separately and then added together. We call these parts terms. This expression has two terms. A term is formed from its factors. But what are these factors? Consider the term 4xy. It is formed by multiplying 4 times x times y. We say that 4, x, and y are the factors of the term 4xy. The factors cannot be factorized further. The numerical factor of a variable term is called its coefficient. In the term 4xy, 4 is the coefficient of the term. Consider 3x squared minus 2xy plus 4y squared. We have three terms, 3x squared minus 2xy and 4y squared. 3 is the coefficient of x squared, minus 2 is the coefficient of xy, and 4 is the coefficient of y squared. When terms have the same algebraic factors, they are called like terms, like 5p and 4p. And when the terms have different algebraic factors, they are called unlike terms, like 3q, 3r, and 4m. Note that 2x squared and 2x are unlike terms. Like terms can be added or subtracted. Unlike terms cannot be added or subtracted. When simplifying algebraic expressions, we add the like terms together. For example, x squared minus 5xy plus 2y squared plus 3xy plus 2y squared. The terms x squared has no like term, so it remains the same. Then we have minus 5xy plus 3xy gives us minus 2xy. 2y squared plus 2y squared is 4y squared, and so we have x squared minus 2xy plus 4y squared. An algebraic expression with only one term is called a mononomial, like 2pq, 5x, xy, and so on. An expression with two terms is called a binomial. For example, x plus y, x squared minus 4y, and so on. An expression with three terms is called a trinomial, like 2x squared minus 4y plus 10. The expressions with two or more terms are collectively called polynomials. Poly means many. Next, multiplying algebraic expressions. We have already seen that the terms of an algebraic expression are formed by multiplying factors, so that 5x is formed by multiplying 5 times x. And so if you're multiplying the term 5x with another constant, you are simply adding another factor. So 2 times 5x simply means 2 times 5 times x, which gives us 10x. 4 times 2x squared y simply means 4 times 2 times x squared times y, which gives us 8x squared y. And so when multiplying an expression with a constant, it simply increases the coefficient of the term. So a half times 4x squared is equal to 2x squared. Multiplication with a variable. Again, it's simply the same thing, only that in this case, we will increase the variables. X times 2y means x times 2 times y. And so we have 2xy because we cannot have x to y. Even if you are multiplying two terms, like 2x times 2y, this is equal to 2 times x times 2 times y, giving us 4xy. 4p times 3pq is equal to 4 times p times 3 times p times q, giving us 12p squared q. Dividing algebraic expressions. When dividing, we check which factor of the term can divide into the divisor and how many times. So that 2b over b, b divides into b once, so we cancel it out. And so the answer is 2. 2b over 2 means that 2 will cancel out and we remain with b. 4x squared y over 2x, this is equal to 2 times x times y over 2 times x. 2 cancel out, x will cancel out with 1x, and we remain with 2xy. Expanding algebraic expressions. When a polynomial enclosed in a bracket is multiplied by a factor, all the terms in that polynomial are multiplied by that factor, so that 2 times into bracket x plus y will mean 2 times x plus 2 times y, which is equal to 2x plus 2y. X into 3x minus 4xy means x times 3x minus x times 4xy, which gives us 3x squared minus 4x squared y. 2x plus 4 into x plus 4y. All the terms in the bracket are multiplied by 4. So we have 2x plus 4 times x is 4x plus 4 times 4y is 16y. So we have 6x plus 16y. Again, if a polynomial is divided by a factor, all the terms are divided by that factor. 4xy minus 8pq, everything over 2, means 4xy over 2 minus 8pq over 2. And that will give us 2xy minus 4pq. 4x squared y plus 2xy squared, over xy is equal to 4x squared y over xy plus 2xy squared over xy. When we cancel out, we remain with 4x plus 2y. Now pay attention to this. 4x minus 3 into 2x minus 3. The terms in the brackets are multiplied by the factor 3 outside the bracket, right? Wrong. That factor is not 3. It's minus 3. And so we have 4x, then minus 3 times 2x is minus 6x, and minus 3 times minus 3 is plus 9. And so we have minus 2x plus 9. 2x minus 4 times x plus 5y will give us 2x, then minus 4 times x is minus 4x, and minus 4 times 5y is minus 20y. And so we have minus 2x minus 20y. Next, fractional algebraic expressions. Now, for a term that does not have a coefficient, the coefficient is actually 1, so that xy means 1xy. Again, remember in fractions, we said that a number can be written as a fraction by having a denominator as 1, so that as a fraction, x is equal to x over 1, or 1x over 1. And so if you have x over 2, it means 1x over 2. And you can separate the coefficient and the variable so that you have 1 over 2x. X over 4 also means 1 over 4x. 2x over 3 means 2 over 3x. We basically add and subtract fractional algebraic expressions the same way we do with fractions, but we only add and subtract like terms. 1 over 3x plus 4 over 5x. The LCM of 3 and 5 is 15. 15 divided by 3 is 5, times 1 is 5. 15 divided by 5 is 3, times 4 is 12. And so we have 17 over 15x, or 17x over 15. 2 over 3x squared plus 4xy minus 3 over 4xy. The like terms are xy. 2 over 3x squared remains the same. As a fraction, 4xy is equal to 4 over 1xy. We subtract 3 over 4xy. The LCM of 4 and 1 is 4. 4 divided by 1 is 4, times 4 is 16. Minus 4 divided by 4 is 1, times 3 is 3. So we have 13 over 4 xy, and we add that to 2 over 3 x squared. How about 1 over x plus 1 over x? The denominator this time is a variable, but it works the same. Compare it with 1 over 2 plus 1 over 2. If the denominators are the same, we simply add the numerators. So 1 over 2 plus 1 over 2 is 2 over 2. So equally, 1 over x plus 1 over x is 2 over x. Now try 1 over x plus 1 over xy. What is the LCM of x and xy? Remember, xy means x times y. Compare this with 1 over 2 plus 1 over 6. 6 is equal to 2 times 3. And so the LCM of 2 and 6 is 6. Equally, the LCM of x and xy is xy. So xy divided by x is y, times 1 is y. Xy divided by xy is 1, times 1 is 1. And so we have y plus 1 over xy. 2 over 2p plus 3 over 4. The LCM of 2p and 4 is 4p. 4p divided by 2p is 2, times 2 is 4. 4p divided by 4 is p, times 3 is 3p. That gives us 4 plus 3p over 4p. Now consider x plus 2 over 3 minus x minus 1 over 2. The LCM of 2 and 3 is 6. 6 divided by 3 is 2 times x plus 2 minus 6 divided by 2 is 3 times x minus 1. We open the brackets and we have 2x plus 4 minus 3x plus 3. That gives us minus x plus 7 over 6. Next is substitution. Now, substitution is simply replacing an algebraic term with a numerical value. For instance, find 2x plus 4 if x is equal to 5. Substitution means wherever there is x, we replace it with 5. And don't forget that 2x plus 4 means 2 times x plus 4. And so if we substitute x, then we shall have 2 times 5 plus 4, and that gives us 14. Next, factorization. We call the process of removing brackets as expansion. The reverse process is called factorization. When we factorize an expression, we make it look simpler and shorter, and that way we say we have simplified. Now consider ax plus ay. This means a times x plus a times y. A is a common factor in both terms, and so we can factorize it out. So we have a into x plus y. 2x plus 8y. 2 is common to both terms because this means 2 times x plus 2 times 2 times 2 times y, which is equal to 2 times x plus 2 times 4 times y. And so we have 2 into x plus 4y. 4x plus 12x, 4x is common. Therefore, we shall have 4x into 1 plus 3. Let's take an example. Simplify 2x squared minus 4xy over 2x minus 4y. We start with the numerator. 2x is the common factor. So we have 2x into x minus 2y. And then the denominator, 2 is the common factor, and we have 2 into x minus 2y. The expressions inside the brackets are the same, and so they cancel out. We remain with 2x over 2. The 2 will cancel out, and we remain with x. There are certain expressions that at first glance may not seem to have a common factor, but a careful examination will allow you to see the common factors. Consider ax plus ay plus bx plus by. The first two terms have a common factor a, and so we can have a into x plus y. The next two terms also have a common factor b, and so we can have b into x plus y. So we have a into x plus y plus b into x plus y. The terms in the brackets are the same, x plus y. So we pick one of them. Then we put the factors outside the brackets together, a plus b. And that expression factorizes into a plus b times x plus y. even if we wanted to factorize out x and y instead of a and b, so that we rearrange our expression to be ax plus bx plus ay plus by. The first two terms, x is common, so we have x into a plus b. The next two terms, y is common, plus y into a plus b. And therefore we shall have x plus y times a plus b. Now consider y squared minus 3y plus 4qy minus 12q. The first two terms have a common factor y, so we have y into y minus 3. The next two terms have a common factor 4q, so we have 4q into y minus 3. And lastly, we have y plus 4q times y minus 3. Simplify x squared plus x minus xy minus y, everything over x squared plus x minus 2x minus 2. Start with the numerator. The first two terms have a common factor x, and so we have x into x plus 1. The next two terms have a common factor minus y, so we have minus y into x plus 1. So we have x into x plus 1, then minus y into x plus 1, so that we shall have x minus y times x plus 1. Now the denominator. The first two terms have a common factor x, so we have x into x plus 1. The next two terms have a common factor minus 2, and so we have minus 2 into x plus 1. So we have x into x plus 1 and minus 2 into x plus 1. And finally, we have x minus 2 times x plus 1. When we combine the numerator and the denominator, x plus 1 will cancel out, and we remain with x minus y over x minus 2. Last example, Joanne rode for x plus 1 hours and covered a distance of x squared minus 2x plus x minus 2 kilometers. Find her average speed. And so speed is given by distance over time taken. That is equal to x squared minus 2x plus x minus 2 over x plus 1. So we factorize the numerator. The first two terms have a common factor x. So we have x into x minus 2. The next two terms have a common factor 1. So we have 1 into x minus 2. Everything over x plus 1. So for the numerator, we pick x plus 1, and then we pick x minus 2. So that we have x plus 1 times x minus 2 over x plus 1. X plus 1 cancels out, and her speed is equal to x minus 2.
And so you can go on and learn math. You may need tutorials, you may need tutors, etc., to get your foundation solid so that you can build the next course on it. But math is not so complicated that most people can't learn high school math and certainly the introductory courses in university. If you want to go on and major in math or do honors in math or do a career in math, you really do need to be good at it. But I think too many people stop out too soon because they've had bad experiences.